Welcome to Pre-Calculus. This is Unit 0, Prerequisite Skills. In this video, we are going to learn about interval notation. It's a pretty important part of really just simple understanding of how numbers are, and we're going to actually use this interval notation in a lot of things we do this year, so it's pretty important that you understand this very basic concept. So let's talk about a little bit about what interval notation is. So when we describe sets of numbers, we often have to describe certain sets of real numbers, all right? So for example, we could talk about all real numbers, all right? That's pretty easy, how you talk about all real numbers. We talk about integers. Hopefully you guys know what those are. Positive whole numbers, negative values, rational values, irrational, whatever, sets of different numbers. Could be a single value, right? We could be talking about a single value. In that sense, we may say, hey, x equals 2, or we might even just put it in like little brackets, like, hey, we're talking about the number 2. It's a very simple number, right? That's it, just that value. Or it could be a range of numbers. Maybe we want to talk about a whole bunch of different numbers, numbers greater than 2, numbers less than 2, numbers in between 2 and 5, what have you. And that is where interval notation really comes in. So there are two ways that we have learned to describe sets of numbers. Two ways we kind of do this in mathematics. We use equations and inequalities. For example, like I said, we might say, hey, x equals 4. That's obviously an equation that tells us that x equals 4. Or we might use an inequality that says, hey, x is any number greater than 4, something along those lines. But an interval notation is really just another way that we can describe a set of numbers in place of using equations or inequalities. Let's look at a couple more examples. So these are three different values, A, B, and C. And these three statements are describing a set of numbers. So for example, this first one here is any number, A, less than or equal to 2. So, most of you way back in the day maybe made a number line. And on that number line, you put the number 2, and you say, okay, this set of this, inequality, this mathematical notation is saying that our values are anything below 2, and then since we're allowed to equal 2, we'll put a filled in dot at 2. So we're allowed to equal 2 or anything less, right? Here, this next one is B is greater than, greater than 5, just greater than 5. So in that case, we might make a number line. We'll put 5 on that number line and greater than 5, any number above 5. But then we got to put an open dot at the 5 because technically it's really, if you think about it, impossible to tell somebody what's the first number after 5. If you ask a little kid, they might say 6, which I see makes some sense. You ask somebody with a little bit more understanding of numbers, they might say, 5.1. But even that's wrong, right? It is literally impossible to say the very first number after 5. 5.0000000000001. I mean, technically even that's wrong. So that's why we use that open dot to show that we start at 5, but just right after 5, okay? Because mathematically, numerically at least, it's impossible to say. This next one is what we call, an interval of values. We're looking at numbers between -2 and 4, but we are allowed to equal 4. So the number line will say -2 to 4. Open dot at -2 because we can't equal -2, filled in dot at 4, and we shade in between. That's all stuff that you guys should already know how to do. So we don't understand number lines, we understand inequalities, but the new thing that we're learning about in this video is interval notation. So interval notation is just simply a way to represent a set of values without using variables or inequalities. So intervals can be bounded or unbounded, and what that means is an interval that's bounded is numbers that are in between two values, or unbounded is numbers that go way above. So for example, that's this example that we looked at right here, this would be considered bounded because the variable is bounded, it's stuck, there's boundaries, -2 to 4, right? It's like a fences, it can't go past those two numbers. Where unbounded would be numbers, like this one right here would be considered unbounded because it goes all the way above 5 without bound. So there's a bound on the bottom half, 5, but then anything above 5 would be unbounded. And intervals can also be open or closed. That goes back to the dots, right? A closed dot means that you could equal that value at that bound, where an open dot means you cannot equal that value, but you're just after it or just before it, which again, like I mentioned, is impossible to describe. So let's look at some examples of bounded intervals. So all of these intervals are talking about looking between two numbers, A and B. So obviously this can be any two numbers, 2 and 3, 2 and 10, -3 and 17, but we're just using A and B. So if you're allowed to equal both A and B any number in between, then we use brackets. So a bracket is if there's an equal to. That means that it's closed. You're allowed to equal that number. So that's a bracket. So this is interval notation. So notice here in interval notation, there's no variable. There's no X, Z, or C, or A, and there's also no inequality sign. This is an interval notation. It just says, hey, we're talking about all numbers starting at A and equaling A, and then going, that's the comma, going all the way to B, and oh, by the way, you're allowed to equal B. So again, that's a bounded interval closed between A and B. In this next one here, we're looking at numbers between A and B, but note, you cannot equal A or B. So that's an open interval, and for open, we use parentheses. So closed, bracket, means you're allowed to equal those values. Parenthesis, open, you cannot. But again, it's still bounded because we're still stuck between A and B. We could also be half open, half closed. So it's kind of half and half, right? So maybe we could equal A, but not equal B. So the interval would look like this. Start at A, bracket, telling you that you could equal A, going all the way to B, parenthesis, telling you that you can't. Or again, we could also look at this example right here where we're closed on the right side with B, we're open on the left side with A, but again, X can be any number in between. So these are examples of interval notation. So interval notation is really just using brackets and parentheses or parentheses and numbers, really pretty much it. Now here's some examples of unbounded intervals. This is where we could go as high as we want or as low as we want. So here's a couple good examples. Here we're looking at all numbers greater than or equal to A. So on a graph, we're going to start at A, where it's a closed dot, right? It's a filled in, but now we're using a bracket, and because that's telling us that we're allowed to equal A, and then go anywhere above A, well, infinite, right? That's where we use an infinity sign. Just to note that we always use parentheses on infinities because you really, infinity is not a number that you could ever actually be. So a bracket, you would never put a bracket on an infinity because that would imply that you could actually equal infinity, which is really impossible if you think about it, right? So always parentheses on infinities. It's a common question I get. So again, that is a closed because you're allowed to equal A, but it is unbounded because you're going all the way as far as you want above it. Here is X is greater than A, not closed, not equal to A. So that's just using a parenthesis on the A, again, going all the way towards infinity. Make sure that when you're doing these intervals, you always are thinking left to right. We read number lines, we read graphs, we read numbers left to right, just like we read a book. So in this next example, we're looking at numbers less than or equal to B. So that's less than B, that's way below B. So now we're going to start with that negative infinity. The negative just means that we're going all the way to the left, all the way down towards negative a billion, negative a zillion, and obviously keep going. And then to the right, because we're always going left to right, is B with a bracket because we're allowed to equal it. Here's another example of an open interval. X is less than B, so the only difference is we're using a parenthesis on the B instead of a bracket, but we're still starting at the left because negative infinity is to the left. And then if your set of numbers you're talking about is literally all real numbers, every single number that you could possibly think of, negative infinity to infinity, well, a number line where you would just shade the entire thing. If you're going to make an inequality, since infinities aren't numbers, you can't put a number on the left or right. And then that makes the notation, the interval notation, simply negative infinity to infinity, meaning literally all real numbers, the entire real number line. So that's it, guys. Those are intervals. They're really easy to make. You just need numbers and infinity signs if you need to, and then the brackets and parentheses. All right, so real quick, when do we use interval notation? We use it in place of inequalities. So from this point forward, I don't really like inequalities. You may have an answer that ends in inequality, but we always want to turn it into an interval notation, which is pretty easy. And anytime we're describing a range of values, if I say, hey, for what X values does this happen? Well, you would give me an interval notation to describe the answer. And again, this is really needed because, again, I kind of mentioned this earlier. How could you talk about all values greater than 5? Because if I said, what's the first number after 5, that's really impossible to verbalize, right? That's why we need the interval notation to say, oh, all numbers greater than 5. Well, you're talking if we can't equal 5, it'd be 5 towards infinity. If I'm allowed to equal 5, it'd be, put the bracket on the 5. So that's important that you understand. All right, let's look at just 3 simple examples here. I think this is a pretty easy topic. I think you guys will understand. So these are 3 inequalities. We want to turn them into interval notation. So always going left to right. So we're going to have -6, comma 3. We are bounded between those 2 values. Bracket on the -6 since we're allowed to equal it. Parenthesis on the 3. And just like that, we're done. This is x is less than or equal to -1. So less than means way to the left. So that's -infinity, as far down as I can go. And then we're bounded on the right by -1, and I'm allowed to equal it. So I'm going to use a bracket, parentheses, always on the infinities. All right, this next one is, again, bounded between -2 and 3. I'm allowed to equal both of them, so I'm going to use some brackets there, okay? So the one thing that I do see a lot of kids do wrong is A, they put brackets on infinity signs. Don't ever do that. And second is they put it in the wrong order, right? So a student might look at this second example and put -1, comma, -infinity. That's the wrong order, right? We always got to go left to right, and -infinity definitely comes before -1. So don't do it in that order. So make sure you understand that. So other than that, guys, it's really just a series of numbers, brackets in parentheses, and some commas in between, and it's really meant to be pretty simple. So that's interval notation. Hopefully you found it pretty easy and not difficult at all.